Today we're going to talk about the atomic structure and go through the evolution of what scientists used to think atoms look like to what we believe atoms to look like now. So some of the key people that we'll be talking about are Democritus, Dalton. We'll also talk about Rutherford. And then we're going to take a look at instruments that they've used to observe these different things about the atoms, as well as what we actually call these parts of the atoms today. Don't worry about taking notes for this lecture. This video will be posted on Edmodo, so you can go through it again in your own pace, so you can fast forward and rewind and pause whenever you need to. So our main focus in this class is really dealing with this word, the atom. You've seen this word before in general science or probably when you were in elementary school, but the atom is the smallest particle of any element and it has to keep its identity in any chemical reaction. So, for example, if I have water, which is made up of H2O, and a chemical reaction occurs with water and some other element, that hydrogen from that water will still remain hydrogen after the chemical reaction. It's just rearranged itself. So this idea of the atom is comparable to, say, your birthday, right? So for many of you, not only do people ask you your name when you go to an important event, so say getting your driver's license or signing up for college, they also ask you about your birth date. And that's because your birth date will never change. It's part of your identity. It's when your identity was created. So, this idea of identity and having portions of us that create who we are is the same thing as an atom. So, atoms have different pieces, and once people look at those pieces, they can tell, oh, this is the atom that I'm working with. So, our first person is Democritus. And to talk about his idea, I would like to read this pledge that we say almost every day after prayer. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. As you can see, I've highlighted this word indivisible. So what I'd like you guys to do with someone to your left or to your right, I'd like you to discuss what the word indivisible means. So take a couple seconds to do this. This means it's okay for you guys to talk. Okay, so let's break this word up into different pieces. So the first piece I want to take a look at is this word divisible. Well, the word divisible has very similar portions as the word divide, right? So to be divisible means that I can be split up, I can be divided, and I can be broken up. However, in English class, or somewhere in the past, you've learned that sometimes we can add prefixes to these words and it kind of tweaks the meaning. So whenever I use the prefix of in, it's actually saying that you cannot. So when I say indivisible, it's telling me something that cannot be divisible, which if I break down divisible like from earlier, means that we cannot break this down. We cannot divide it. It must stay in its own way. So Democritus believed that the atom was indivisible. He said that, well, there is this thing called this atom, and it makes up everything that we use. However, that one atom can never be divided. And so a few people checked and researched to see if this was true. So next came Dalton. So Dalton said, okay, well, I kind of believe what Democritus is saying, but I think he's missing a couple pieces. So one thing he said was, all elements are composed of these tiny indivisible particles called atoms. So he did agree with Democritus on his definition of an atom. However, he did add a couple things, so let me scroll down a little bit so we can show all these different pieces right here. He also believes that atoms of the same element have to be identical, just like identical twins, right? Identical twins, everything has to be the same. Their DNA is the same, the way they look is the same, the way their height may be the same, but he believes that an atom of hydrogen has to be exactly the same as another atom of hydrogen. His next idea was that atoms of different elements can physically mix together to chemically combine in simple whole number ratios to form compounds. So, as we've spoken before, we know that things can go through chemical reactions. So, once a chemical reaction happens, it's okay to chemically combine things to, say, get H2O. But one of the key things is that it has to be a whole number ratio. So, for example, I can't have half of a hydrogen react with an oxygen. I have to have a whole hydrogen atom to react with this. And that stems from the idea that things are indivisible. Okay? A couple more ideas that Dalton said is that when I have a chemical reaction, and this right here is my abbreviation for reaction. When a chemical reaction occurs, um, atoms are allowed to be separated, joined, or rearranged. So, if I already have a compound that's made up of different atoms, I'm always allowed to separate them and I can join them back together, or I can separate them and rearrange what I have. So if I were to draw, let's say drew a couple of these shapes, okay? So here's like, let's pretend this is a different building that I have, right? Well, what Dalton is saying is it's actually okay to break these apart, right? So right there, I'm separating, like what he said. I can join them back together, like that. Or, once they're separated, I can rearrange it. I can say, okay, well, these two are going to be together, but this one square, he's going to be alone by itself. That's completely allowed, okay? It also says atoms of an element are never changed in the atoms of another element into the atoms of another element as a result of a chemical reaction. So even though I separated this square from this triangle and this heart, it's always going to remain this square. There's no way for me to change this one little square into a heart or into a triangle. It must remain this square. Okay? So what I'd like you guys to do is to finish reading chapter 4.1 and 4.2. So when I return, we can discuss subatomic particles as well as Rutherford experiment. And please make sure you complete the reading guide as well as page 103, number 4 and 5, and page 108, numbers 11 through 14. These will all be collected on Wednesday when I see you next, and these will also be posted on the website. Thank you and have a great long weekend.